All right. So in this section, we are going to look at how we can handle skewed data. So skewed data is basically if our data set has got outliers, like what I've mentioned, they can negatively impact the performance of our learning models, right? So scaling the features can actually help us in handling such cases, right? By transforming the data to a standardized range where it reduces the impact of extreme values and makes our model more robust, right? So, so in this case, if your numerical features, you've got different scales, it's basically a good idea to be able to scale this data, to standardize the data, so that there will be maybe in a standard deviation of mean 0 to 1, right? So that's the range that we want to do to handle our data. So the way we're going to do this is we're going to use a standard scaler from sklearn, right? Like what we did with the label encoder. So let me simply go ahead and import the standard scaler, right? So this is how you import the standard scaler, right? So before I do that, let me just put some notes here for your reference. So remember, these notes are also available in my article, so I'm simply going to copy the notes and then paste them here. So these are the notes, right? So let me just save it here. So this is basically what we're simply trying to do, right? So first of all, I'm going to import a standard scaler. So once I import a standard scaler, I now want to come up with the numeric features, right? So the first thing that I'm going to do here is I'm going to say I'm simply going to create an array called numeric features. So basically here I just need to extract all columns, right? I need to extract all columns with our numeric data. So in this case, I'll say numeric train data. Then I can say so in this example I can say select type. So we already know that this data set it's of type int64, actually all of it if I'm not mistaken. So just to be sure, let me just quickly, before this, let me just go ahead and print the info here. So let me say info. Yeah, so all of this data set is int64. So here I'll simply say int64. Right, so here I want to get all these columns, right? Then once I get this int64, I need to get the actual columns, right? So I can do columns.select the data types. And then once I get these columns, I'm going to convert them to a list, right? So I'll reduce them to a list. So this thing, we have a list of numeric features, right? So it will just have a list of these things. So let me just print it here, right? So it will have a list. So in this case, age, balance, day, and so forth. There's something that we are missing here. So this is numeric train data, not numeric columns. So this was the old one, so I'm supposed to use the latest one. Okay, let's do it again. Yeah, so all columns, since they're all numeric, like what I've seen from this info, I can simply print them here. Okay. So once we have done this, I'm simply going to delete this. Okay, maybe I'll leave it there for your reference. So once I've done this, the next thing that I need here is a scaler, right? So I'll initialize my scaler, then I'll say standard scaler, right? Then for my standard scaler, I'm simply now going to say my numeric train data. It's almost similar to what we did. Then I'll take the numeric features, which is basically all these columns. Then I'll say scalar, because I'm simply going to apply it to the whole data frame. Scalar.fit transform, right? Then I'll say numeric train data again, right? So I'm simply passing the numeric train data with basically our numeric features here. So probably I need to put this here. So I'll say numeric features. right? So what this does is it will replace, right? It will replace all these numbers, right? All these numbers in our trained data set with whatever the standard scaler is transformed our new data set to. So here we're applying it to the whole data frame. So let's run it. So if I run it and then I check the numeric trained data, just copy and paste, you can actually see that our data is now scaled. So as you can see, like what I've mentioned here, if your numeric features have different scales, it's usually a good idea to standardize them to have a mean of 0 and a standard deviation of 1. So you can use a standard scaler for this. So in this case, you can actually see that the standard deviation is 1. That is separated in this data set, and for the most part this data, they're sort of like in cross proximity instead of jumping from one data set to the next. So this data is now scaled a little bit. It's now scaled actually. So this is what you want to achieve, right? So we have done this for the numeric test data. So we now need to do the same for our we now need to do the same for our tests. This was for our feature, this was for our training data, so we need to do the same for our test data. So to do the same, I'm simply going to say numeric features again, then here instead of train, I think it's test data, right? Then I'm simply going to copy these two again, standard scaler, and then instead of test data here, it's now instead of train data, it's now test data. So I'll simply apply this. Then if we can view the tests, you can actually see that it has done the same thing, right? So the data set that we now have is now scaled, which means our data set is no longer jumping from one data set to the next using the mean deviation standard. What it means is our features, for the most part, they are now ready to be put or to be trained in our neural net, right? So let's just quickly look at this shape. Let the shape of this. So just a quick look. So you can actually see that we have this is test data. I want to check the train data. So for our train data, yeah, we have 45,000 records with 15 rows, right? Which is what we expect. Then in terms of our dimension, we haven't changed anything. So here, if I can say, let's just quickly check out our dimension. In this case, it's still 2. So which means our data set is still a 2D tensor, which is a vector, right? So vectors and our labels are scalars. So that's good data to deal with, right? That's a good scenario. So the last thing that we probably need to do, so here we've handled our features, but remember our labels still had if you still remember from our training labels, it still had it was still in its categorical format, right? So if I can check our labels here, our labels were still like this, right? So we also need to convert these numbers, these strings to numbers, right? Because for us to pass these training labels, we need to be able to convert them to numbers as well, right? So here I'm simply going to write one last section called handling labels, right? So for handling our labels, in this case, since it's a binary classification, we only have 2 data types. Here I'm simply going to use one hot encoding, right? So here for labels, what I'm simply going to do here is I'm simply going to introduce a new variable called one hot encoded train labels, right? I'll simply say I could potentially use the label encoder, or I could potentially use the dummies. So in this case, for consistency, I'm simply going to use the label encoder. Then I'll say dot fit transform then our train labels. So I'll also do this. I'll also do the same for our test labels. Oh, I've cut this instead of copy. Right. So this was for our train I'll also do the same for our test. This is for test labels, right? Boom. So I run this, so I take a look at this, right? Boom. So it's an array, so it's a scalar, which is exactly what we want. So up to this point, we have successfully handled our features and labels and represented as numbers, right? So in the next section, before we build our model, I think that's the last thing I promise. We now need to be able to separate our training data set, our validation data set, and our test data set. So here we already have our test data set, which is good, which we have our test data and our test labels. So we use it at the end. And then we have our training data set. But from this training data set, we actually do not have our validation data set, because as you are going to train our model, we need to be able to validate it to see if it's actually doing a good job as you are training it. So which means we need somehow to extract some validation data from this training data set. So one rule of thumb, whenever you are building your neural network, you should never train your model or you should never test your model or validate your model with the data that it has seen before, it has been trained before. Because what you want to see here is want to see if our model can actually go ahead and generalize well, right? So we don't want our model to cram or to memorize some things. We need it to be able to start to generalize the data based on the data that it has not seen before. So when you train it, we're not going to mix the training data set and the test data set. We are also not going to mix the training data set and also the validation data set. We're going to separate these three data sets. So in the next section, we'll look at extracting the train, validation, and test sets. I'll see you in the next one.